Okay, so put back on the recording so that we can get that documented for you. So yeah, just say it again. So hey guys, welcome to the WUG. We were just talking about PEARC. So if any of you guys are going to PEARC, well, the Warewulf Birds of a Feather is going to be on that Wednesday, 1:30 Central Time. So I'll put some notes and stuff in the Slack for you. But Alexi is going to be presenting. So tell us again when and where and the topic of your presentation so that we can
Yeah,
all.
it's gonna be on Monday, on the SIG HPC session devoted to replacement of XCAT. And the presentation of Werewolf, as far as I remember, is gonna be in early afternoon, like 12:30. I gonna check the schedule and update you on that.
Yeah.
And
Yeah.
again, just thank you very much to you, to Jonathan and team for reviewing the slides and giving me very good suggestions. So it was very helpful.
Yeah. Yeah. That's awesome. Yeah, that's gonna be a great one. I'm gonna have to look at my calendar. I don't know what day I'm coming in. They always do the cool stuff like right in the beginning or right in the end, and
That's true. Yeah.
yeah.
So people either leave early or come in later and miss it, right?
Yes, that's exactly. Yeah, that happens oftentimes, especially because, we often are a vendor. So, like, the vendor days and hours are kind of like squished in the middle. And then I forget that
Yeah,
there's
yeah,
other
you're right.
things going on the sides. Yeah. So, thank you for that
True.
reminder. Yeah, cool. Hey, Timothy and Bruce and Rich and David and Jesse and Christian. Welcome. Um, and Josh, cool, and Joe. Yeah, okay. So Jonathan just let me know he's going to be a few minutes late. So we will still get started here for now. Let me desktop 2. I think that's what I want. No, this is what I want. There we go. Perfect. Okay, you guys. So this is our July WUG. We are going strong. Pretty cool. Today we have some topics on the agenda: Grace Hopper and multi-arch support in Warewulf, and then also Enterprise Linux 10 and Warewulf. So there were some some questions around that. So these are some topics that we're going to bring up, and of course we want your guys's suggestions and ideas and experience. So real quick, Warewulf is an open source stateless provisioning system for HPC clusters. It boots and manages compute nodes over the network without local disks, scaling from small research clusters to large HPC systems. Warewulf version 4 integrates modern container technologies, provisioning containerized OS images directly to bare metal. It's vendor agnostic and backed by OpenHPC. It's used across universities, research institutions, and enterprises worldwide. All right, so here's today's topics. Let's go to the next one. Cool. Okay, so today you got me giving you a little welcome. I help out in the community. If you guys need anything, Jonathan is going to be here in a few minutes. He'll be doing some updates. We might kind of move things around a little bit for his schedule. And then Josh Burks from ASU is going to be getting some conversation started with some Grace Hopper information, which will be great. And then, of course, we're going to have open discussion. Just a little update on the community. Thank you to the members of the Technical Steering Committee. That includes Gregor Kurtzer, Jonathan Anderson, Christian Gall, Timothy Middlecoop, and Jeremy Seidel. And you can see that we are a highly functioning and well-supported community project, open, available to everyone, and supported by a variety of different people and companies, which is really nice. Our Slack is growing. I don't know if you guys noticed last month. It was $6.99 and now we're at 706. So slow and steady, the community is growing, and it's wonderful to see all the new faces and new people inside the community and also at the WUG. So maybe we can remember to invite them here as well. Technical Steering Committee actually meets the first and third Wednesdays of every month via Zoom. Everybody is welcome to come. We encourage you to come, kind of see what's going on and have your 2 cents on the roadmap and what's happening, and also just be part of it. YouTube is good. We've got 53 subscribers, Bluesky 38, and we are also on x.com with 29 followers. Oh, okay. This was actually from last month. So I will just stop the presentation now because we already did that particular update. Oh. Cool. Okay. Hey, Shane and Ian and Fong and Kyle. Good to see all of you. Timothy or Christian, did you guys want to step in and do any updates from the last WUG that we had for the community, or do we want to wait for Jonathan for that?
I didn't prepare anything, so we have to wait for Jonathan for that.
Okay, that's fine. Yeah, I know it's kind of last second, but I didn't know if you had anything that you wanted to share. Okay, perfect. So today, Josh has graciously accepted the request to get the conversation started here. So Josh, thanks so much for being here.
Yeah, thanks for having me. Should we wait for Jonathan, or do you want to
Yeah, no, I think that
just
he
move
can
forward?
kind of pop in and do updates when he gets here. So yeah, I think if you want to get the conversation started with the Grace Hopper stuff, I think that'd be great.
All right, let me see if I can share my screen. Do desktop one. Okay, can you guys see that okay?
Yeah.
I'll try to have the chat open here. I just know when you're sharing, Zoom likes to do fun stuff with the other windows. Yeah, well, hello everyone. My name is Josh Burks. Rose gave me a pretty good introduction already with Arizona State University. I've been working with them in Warewulf for, gosh, like 3 years now. How time flies. A little bit of a recent update. Personally, I am no longer located in Arizona with Arizona State. I still work there, just fully remote now from the Pacific Northwest up in Seattle area. So that's been very fun. And I'm going to talk a little bit about our Grace Hoppers that we have in our cluster and what the experience has been like managing those with Warewulf. If you're not familiar by now, Grace Hoppers are NVIDIA's really cool super chip with a Grace CPU, Hopper GPU, and this fancy NVLink chip-to-chip interconnect that allows the CPU and GPU to communicate over a very high-speed bus and share memory. But this is a specialized chip, so it's not running x86 64 instruction sets. It uses ARM Arch. But the advantage there is that the GPU can access the CPU memory. So that lack of support for x86 64 is part of what makes the chip so cool, and it's also what makes it a big pain to manage. The operating system, your kernel, your init ramfs, all your userland, RPM, or deb packages, all your libraries, software stacks, and applications all have to be ARM native in order for it to work on these super chips, which is a huge hassle as a system administrator. It's basically spinning up an entire second copy of all of your software for this one or many nodes that you have. But the advantage is it has that unified memory where the CPU and GPU can share system allocated memory through a shared page table across that really fast interconnect, which allows the GPU to theoretically access up to 600 some gigs of memory for massively for GPU workloads that benefit from that massive amount of memory. But it's fairly new technology still. I mean, ARM has been around for a while, but widespread support for ARM has not necessarily been around for super long. So not every package wheel or vendor tool will support these Grace Hopper super chips. Although with Apple switching to Apple Silicon several years ago, support for ARM in general has grown tremendously. The other challenge with these nodes is making sure your users know what they're doing. If you tell them I have a GPU with 500 gigs of memory and forget to mention that it's ARM Arch, they're going to be very disappointed.
I see some nodding of heads there.
So this is a diagram I ripped directly from NVIDIA, kind of describing that architecture. These chips are gaining popularity already. I think they came out about 2 years ago now, or at least ASU got their hands on one about 2 years ago. And already this GH200 super chip has made up 4.2% of the top 500 supercomputers list. Although there's also the new BH200, that's another 0.4%. So I'm just going to round it up to about 5% of the top 500 supercomputers are running Grace Hopper Superchips now, or equivalent NVIDIA Superchips. Does anybody here in this call have a Grace Hopper in their cluster right now? See one?
Yeah, we have 8. No, 10. We have 10.
Awesome. Is
George
that
Washington.
what percentage of your cluster is that? Is that like half of it? Is that just like a couple 10 nodes out of 1,000?
Oh no, that's 10 out of like. Well, it's like what do we have, like maybe 250 on the main cluster,
Okay,
and those are all
so
x86 nodes.
Yeah.
So these
a
are
decent
special.
chunk.
What, like 5%, I guess.
It's crazy the amount of effort you now have to put in to maintain just 5% of your cluster.
Yes.
Yeah, we're in a similar position at ASU. We have a total of 4 Grace Hoppers now out of 289 nodes. So a very small percent. One of those we own like as like publicly available to everyone, and 3 of them were bought by a faculty member. So we have to have this separate partition that also takes into account condo model Grace Hoppers, which has been fun. Yeah, and I see in the chat there the DGX Sparks, which I think use the same chip, or at least the newer DGX systems do.
Yeah,
Not
it's kind
mistaken.
of similar. Yeah, but but on the other hand, it's like the Blackwell version of the GPU, not the H, it's B.
The what do they call
Yeah.
it? The Grace Blackwell.
Yeah, right.
Yeah, I like the Grace Hopper naming because it was named after
Mhm.
the famous scientist. Although I think Blackwell as an architecture is also named after a scientist, just not their first name
Yeah,
wasn't Grace.
possibly.
But yeah, these things are taking off. So the performance of these is incredible, especially for their value, especially when they first came out. So excited to see where this technology will go and how it's disrupting the long-standing x86 64 space. Let's see. But by having these in our Warewulf cluster, we have to take into account that specialized unified memory when we're provisioning statelessly. So with Warewulf typically running your entire operating system in memory, that memory is kind of the whole point of a Grace Hopper. It's a unified ecosystem. You wouldn't want to put your typical Warewulf image onto your GPU memory. And although you're not, it's still CPU memory. Through the shared page table, the GPU can access that memory. So you don't want to waste that precious, expensive memory with a root file system. So you really should be moving the root file system to a local disk. Like I think most of them have an NVMe. Ours also came with a 2 terabyte spinning disk. I was able to get it to provision to both of those just by loading the right kernel modules, which I think was just generic NVMe, and then a special one for the spinning disk in there, which I'll have to pull up in my container file or overlays here at the end. But because we have these special node images, we have to build them on our existing Warewulf host. So we need an ARMArch64 root file system. Typically, unless your entire environment is filled with Grace Hoppers, like I think NCSA's new Delta AI is exclusively Grace Hoppers. They might have an ARMArch host they can use, but we don't. We're still on x86 for 99% of the cluster, including our provisioning host. So when we try to enter one of these ARMArch containers, it's going to fail with an exec format error because the bash binary inside this chroot is an ARMArch binary. Linux does not know what to do with that. So we need some sort of translation layer. And that's going to be the miscellaneous binary format with the QEMU quick emulator's tiny code generator. Miscellaneous binary format is a pretty cool Linux technology. And then QEMU is the actual translation layer that we're all familiar with. But it uses this really cool just-in-time binary translation or tiny code generator to mimic the CPU architecture of ARMArch64. It's really cool how it all works. I'm going to dig into that a little bit more in a second. And then this technology The miscellaneous binary format is a Linux kernel feature that allows you to register specific foreign binaries, magic bytes, to be processed by a specific interpreter. This is already used in various other programs like Java. It's how Java can run through the Java virtual engine by registering with this special Linux command. And also I found out WSL1 used this to call Windows programs from within the Linux command line. And Wine does this as well. So QEMU's user mode translation layer is going to grab your instruction sets and fake all of the registers with a fake CPU and translate code on the fly while hooking into these syscalls. Because ARM-Arch64 syscalls will be a little bit different. QEMU makes this process all so smooth. And while it sounds like magic, it's actually so incredibly easy to set up, especially if you have a container architecture already. Just run one of these 3 commands, and like magic, it just works. After running that, you can see from the proc file system all of the different emulators that are registered here. And if we look at one of these, we can see how it's actually linked to an interpreter, what magic number it's looking for, what flags it's looking for, and everything. So on our x86-64 host, you can verify that with uname-m. We run that container command and then can immediately shell in and see that we're faking ARM-Arch64 architecture. Just one command, and then everything just kind of magically works. But when we have these multiple containers, it's really important to maintain consistency, especially across one cluster. If you have your 200 x86-64 hosts and 5 Grace Hoppers, you really want those to be as similar as possible, except where explicitly different. So the OS release, if you can keep that the same, site packages, which NVIDIA driver you're running, which OFED or Doka drivers you're running, your monitoring and security agent. So it's really important to automate your build as much as possible with whatever tools you like to use, whether that be container files, Ansible, a makefile, just a bash script or some sort of CI job. So for ASU, when we like to, I say we, like my coworkers know how to use Warewulf, it's still just me. So I like to put all my RPM packages into just one giant list, pass that into my container files, and then run a DNF install through that. That way, if I want to add a new package, I add it in one place, and all 8 of my container files will start downloading that new package with the list. We throw things like no best and skip broken in there just to make sure the build will continue. If there's slight variations between the repos, between Rocky 8 and Rocky 9. When I was going to build a Ubuntu container for fun, a couple weeks ago, I had Claude translate this list of packages to a Debian compatible list of packages. And surprisingly, it worked on the 3rd prompt. Another important one is your NVIDIA driver versions. So users have the same experience on both sides. I like to use environment variables as much as possible. So I'll pre-stage my NVIDIA driver version, and then inside the container file here, just template it all out with these variables so we can pass it into one place. And then to update our NVIDIA driver, we just change an environment variable and rerun the build, and it automatically pulls down and builds the latest version without having to update 8 different container files. So I use a makefile to do these builds, and I have a snippet of what that podman build command looks like and how I'm passing in all those environment variables. I just pass in everything to everything. We've got the NVIDIA version, Habana version, Habana being the sort of Intel Gaudi equivalent of CUDA. So we'll pass that into the same containers. And if you don't use the environment variables, you don't use them, but it's better to have them and not need them. Circling back to Grace Hoppers, these things specifically really like to have the 64K page size kernel. Thankfully, since we're building in a container, we can just uninstall our kernel however we want and then reinstall the new one. So I have these little blocks here to just remove everything kernel related and reinstall the 64K version of that. And then when I want to target it specifically, I use those RPM commands and have to manually add the little plus 64K at the end because otherwise it doesn't show up and I'm linking to the wrong kernel. Other gotchas when you're doing multi-arch stuff, your Warewulf client or your WW client binary needs to match. In a fairly recent release of Warewulf, I want to say it was 4.6.6. Correct me if I'm wrong there, but actually updated the default overlays to ship with multiple architecture versions, which has been a huge help because I'm not manually compiling WW client anymore anytime I update Warewulf. So just making sure you select that right overlay. You also need to make sure you have an iPXE binary compiled for ARMArch64. I think the new versions of Warewulf also kind of just automatically do this by pulling in precompiled binaries. I had built my own binary 2+ years ago now, and I'm still using it because it still works. The overlay contents are also really important. If your overlays contain binaries, like if you have precompiled scripts or Prometheus exporters in there, you have to make sure you update those to include ARMArch64 versions or move those off to an NFS file system and template the paths. Repositories are also different. If you template your repositories, make sure you keep those up to date. And then not directly related to Warewulf, but your scheduler policy is how your partitions, constraints, features, GRES are all set up so users know when they're landing on these architectures. Maintaining all that software is quite a pain because you have 2 full software trees to maintain. SPAC, Easy Build, and other build systems can automate this. We use SPAC, and it's actually pretty great for this. Most of the time, I can just tell it to install for this architecture, install for that architecture, and I don't have to think about it too much. But it's definitely a pain to add a Grace Hopper into your system after it's been fully established and built out as a cluster for several years, because now all of a sudden you're duplicating years and years of software builds, and there's a specific hierarchy in there already that you have to disrupt to add all these extra modules and make sure they get into user paths appropriately. Documentation is probably my enemy. I hate writing it. My users hate reading it. But unfortunately, it is necessary so users know what they're doing when they're on these nodes. So this is kind of where I wanted to drive the discussion, is how other people are doing multi-arch clusters. Like I said, we use SPAC. We maintain a totally separate module tree where we template the module path variable through an etc profile D script. But I'm curious how everyone else is doing it. What works, what doesn't work, how much your users use your Grace Hoppers versus the other systems, what kind of applications they're running on them, how you go about supporting and maintaining them. My favorite example of a pain point is VS Code. My users love VS Code, and I'm pretty good about updating it, but I always forget to update it for ARMArch64 because I think there's 2 people total that use that build. But every time I update it, I have to remind myself, wait, I have to go and do it again in this other package tree or else VS Code is going to fail. I had to retemplate a bunch of stuff to get that working.
Is that in your SPAC tree that you have that?
VS Code? No, it's a precompiled binary you can download from Microsoft.
Yeah.
But it's still for
You
a
just have to get
specific
it in place.
architecture.
Okay.
Yeah. I finally automated this last month. I got sick of updating it and finally I wrote a bash script. I had Claude write me a bash script to go and download the latest version and update the symlink and everything for both architectures. So there's a little snippet of how I'm doing the module trees. So you can see if the architecture is ARMArch, then we're going to set the module path to this, where we reference this .arm folder here. So normally these are all hidden modules to our users. They're always there, but they never know to use them. Unless you're on this node, then those will be in your default module path. But yeah, does anybody want to talk about their experience with multi-arch clusters? What works, what doesn't work?
I mean, we're still building it up on the Warewulf side to add throw a wrench into it. I'm sorry, I have it circled back to the Slack channel, Tim and Ian. But this was my issues with IPv6, where IPv6 single stack on the Grace Hopper cluster. So it's causing some issues. I think on the iPixie side from the boot, from what I saw. I built my own, and I also rebuilt it with like debug flags, but it's still taking a while for everything to time out. I haven't had a chance to dig into it, but it does eventually boot. The Yeah, we don't really have anything too different than what you have here. Like the module trees are different. We use LMOD.
Do you guys use LMOD the way it's supposed to be used with actual hierarchy? Because we have LMOD too, but we don't do the
No.
hierarchical part of it.
We try.
Yeah, users just it's too confusing for the users when they want to load, say, NAMD. They're like, why do I have to load GCC? I don't know what that is. I just want my software.
Yeah, we have it's all shared on GPFS, so we have like it's just like a separate module, like a path to it. So it's
Okay.
we broke it up somewhere up on the tree where it goes x86 or AR64.
Yeah,
I do
figuring out
have
where
a
to do that was a challenge because SPAC
yeah,
already had like a pre-established tree. I can't make it go into a parent directory, so I had to use a subdirectory. Otherwise, I'd
gotcha.
be rebuilding SPAC. If you're building a cluster from the ground up, multi-arch, you can design around those things from the beginning. But when you add it, after several years
Yep.
of an existing cluster, it's a little bit more challenging to make it all
Mhm.
work together nicely.
Yeah. As far as like deployment, I think what I'm trying to do is like the end goal is to have this deployable through a pipeline. So we instead of makefile, I'm using a container file. What's in flux is the pipeline itself. Right now we're on GitHub, but we have a mandate for IPv6 only, and GitHub does not support IPv6. So
Oh, I'm so
we have
sorry.
we have to drop GitHub. So I'm not going to pursue GitHub Actions. Probably look at some other tools or a combination of tools to do that. But the goal would be a container file. Right now is built just on one of the Grace Hoppers, and push it to a repo, a local repository, Warewulf import. That would be the pipeline whenever there's like a
Okay,
code
that
change.
sounds solid. Yeah, building natively on a Grace Hopper would be much faster because the
Yes,
QEMU and bin format works. It works. It's so slow compared to native.
takes a
Um,
bit.
Especially like Mellanox drivers or Doka is the thing that just takes
Yeah,
literally 90 minutes to complete. So I'll
I can
build
imagine.
all my other container files in less time than it takes to build one Grace Hopper image. Um,
I've
so
never
I still update it, but
I've
it's always
never
a pain
actually
point.
done it this way, but I've imagined doing my SPAC builds as a job in the cluster. Is that something that anyone has like toyed around with or played with, or do you just have like a Grace Hopper system node that you do that in?
We've done jobs in the past,
I know folks
but
that
I'm
do.
lazy and just sneak onto a Grace Hopper node when it's idle. Sorry, Timothy.
That's
I
actually a
know
good
folks
idea.
that have done it as jobs in the past. They have a special preemption / high priority queue for sysadmin stuff.
Nice.
Yeah,
Yeah,
play
I
with
can
that a
almost
bit,
see
not SPAC.
it's also necessary for training if you want to, not training, testing, seeing what's going on with the cluster. You don't want to wait 8 hours to get on a Grace Hopper node.
I'm surprised at how idle ours are most of the time. We have a couple users who really hammer them, but when they're not doing any work, those things sit idle for the vast majority of time. It's somewhat of a lack of education. We try to tell the users it's there, but they don't want to change their workflow. They're like, no, I just need it done. I need it consistent for how my PI told me to do it. But for
Yeah.
those adventurous users, having that unified memory has been great.
You
Oh,
can
for
always
sure.
backfill with OSG, the Open Science Grid, right? And
Oh, I hadn't thought of
give
that. Do
give folks.
they support ARM Arch jobs?
Yes, I believe so.
They do.
And,
Yeah.
and there's a lot of GPU demand for that. So, and it's
Ooh,
fully
I will.
preemptible, so those jobs will go away immediately. And they just have Slurm glide-in plugin, so the OSG framework just sits there. And if you want, they will even manage the terminology there is different than I'm used to, but they'll manage the submission node framework for you, and so they'll just submit jobs from the OSG and keep your system running full. And then you can also, since you're contributing, you probably can get some priority on those as well. So your local users can use the backfill OSG with priority.
Yeah, I have to talk to my coworker who's managing all our other OSG stuff. That's a really good idea to put these otherwise idle Grace hoppers to use.
Um, Josh, I do have a question. So I recently just got the systems to boot properly. Yeah, using Warewulf. It's just because we also have like aside from NVIDIA, is the GPFS stack and identity service. They were not playing nice together, but eventually got that working. Um, the issue now is I am trying to provision a disk, but I can't get it to switch root properly. That's like the next hurdle. So are you booting from a disk
Yeah,
after provisioning?
it provisions, pulls into memory, and then dumps to disk.
Yep.
I am still using a legacy stack that I had thrown together before there was really proper support for it in Werewolf 4.
Okay.
So it's all done through the init script. It's not using the new fancy proper overlays, but just a custom script that runs at init, loads kernel modules, finds the disk, provisions the disk, and switches to it. That script is on my GitHub there. If you want to check it out, it
Okay.
could just
I'll
be
take a
a
look.
matter of loading the right kernel modules or something specific with your hardware vendor. We have a Quanta QS something, like the very first gen Grace hoppers
Yeah.
that we were able to get our hands on.
QCT SG74U or something like that.
I don't know how
U2
you have that
UU.
memorized, but yeah,
Me neither.
exactly.
I have a
The
weird
one with the really
memory.
loud fans that you can hear from
Yeah.
across the room. Yeah.
So you mentioned you have spinning disks. These are the ones we have only have NVMEs, which might also complicate things a
I
little
know
bit.
ours has a 1 terabyte NVMe and a 2 terabyte something. I thought it was a spinning disk. It's also possible it's an SSD that's just not
So
NVMe.
yeah, potentially it could be also an onboard like a SSD. I would think just like for booting, and then the NVMe for like in the front for storage. Um,
That would make sense. I think it shipped with Ubuntu on one of those two disks, but it was 2 years ago now, and I wiped it immediately.
yeah, yeah. I don't even know if it came with a OS.
So
Um, mhm.
in the current world order, I think that it's in like slash werewolf slash deb.init.d, something like that. There's a directory that you can drop scripts in. And so you could do like module loads in there to make devices appear that aren't being auto-detected otherwise. And then you should be able to do the regular provision to disk stuff. But yeah, if there's it, I would not at all be surprised if the Grace Hopper servers you're running need extra kernel modules loaded to access their disks.
That is likely my issue. I was trying I was looking at the documentation on Werewolf 4.7, trying to do drag cut,
Hmm.
and then provision a disk, but something is not working. I did verify that www.init is no, what's that module? Ignition is formatting, partitioning and formatting, because I tested it with like just like a scratch partition, but it's not creating a root or switching over to it. It just hangs.
Oh, so it can see the disk, it just won't switch to it.
Yeah, I'm not
That's
sure
weird.
what the holdup is.
Hmm.
I'll probably enter like a support ticket or something.
I
Like
was gonna
I
say,
could
you
use some
guys have a
help
support
debugging.
contract, right? So we should
Yes.
be able to help you out there.
Okay.
And for the record, I believe Dracut, you can tell it to explicitly force load modules as well, or include them in.
Oh, that's true. Yeah, I
Yes,
forgot
yes, you
about that.
can.
The browsers for that.
I've been doing that for some
Okay.
more ZFS stuff, but I have not bothered to port over this to the new proper scripts because it still works. It's not broken, don't fix it.
We need you giving feedback on the new stuff though, Josh.
It works. It works great.
So I'm curious for opinions, Josh, from you, but really from anyone in here. So that there's point taken on you don't want to use up your HBM for the werewolf image, and so you want to get it out of memory and onto disk somewhere. Um, the what you're doing is I think the most obvious thing, the most straightforward thing of provision a partition somewhere on disk and then load your image there. That makes sense. Another thing that I have had in the back of my mind for a while and recently finally proved to myself that it works. And it's documented in the Werewolf docs. If you can find it, I can put a link to it in the chat also. Is provisioning a scratch partition, not scratch, a swap partition, and then using the Linux memory system to evacuate the image from memory into swap, and do it that way. I'm curious what people think of that. Is that useful? Is that too much, like too indirect or too much work? It is just having a swap partition there too much of a risk anyway. What do you guys think?
My feelings are that we have swap disabled across the cluster because we don't want it swapping to disk because that's slowing a user process down. And there's probably ways to tune what gets swapped, what doesn't, based on C groups or something. But aside from login nodes, we don't really do anything with swap.
Yeah.
I love the idea because in theory, the Linux kernel would do that properly, would move things it doesn't need to disk. It's putting a lot of trust in a piece of software.
That's fair. And yeah, that's exactly the risk associated with it, right? Is you have to make sure your configuration is right so that the user code doesn't do that.
Yeah, we just go and killer takes care of it. We don't. I don't think we have a policy for swap. We didn't really think about that, but we are also running on a slightly older. Like it needs to be refreshed. So I don't think we don't have like NVMe's or we should have SSDs at the very least on the physical hardware.
Yeah.
So I don't think we would want to use swap if the option was there for us at the moment.
You mentioned running something older, which reminds me of a recent pain point with my Grace Hopper is I can't get it to boot anything newer than Rocky 9.5. 9.6, 9.7, 9.8 all immediately throw a machine check exception as soon as
Oh,
the I was debugging this. It was specifically when we get to creating device inodes. I'm blanking on what the systemd name for that was now, but immediately machine
It
check
fails in
exception every
user
time.
space.
User
Like,
space. Yep, I could boot it to
wow.
systemd emergency mode, and then as soon as I start trying to run through those steps, it machine check exception every time. And I've kind of narrowed it down to something with a new feature in the 9.6 kernel for an NVIDIA specific queuing system that isn't compatible with the queuing system that my firmware expects on the node. So I've reached out to the vendor to try to get a newer firmware because I think it's about a year old now, but it's still listed as the latest available. But that's been a pain with all these, AI local privilege escalation bugs that have been coming out that you need to update your kernel for. Well, I don't have a kernel I can update to right now, so I've been having to pass in kernel arg after kernel arg to disable these modules and subsystems to mitigate against that. Even though all the POCs were designed for x86, I know ARMarch is still vulnerable, and it's not likely it'd be exploited, but better to be on the safe side. Apparently, the new version of MATLAB for ARMarch is coming out soon, and we're going to be beta testing it for them. But it requires a version of glibc only available in Rocky 10. So yesterday I was building a Rocky 10 ARM Arch image that I'm going to try to boot today and see what happens there. Very low expectations it'll work without a firmware update, but fingers crossed.
Yeah, fortunately, we don't have that issue. I haven't come across it. The my container file just does like a DNF update, which we need to lock down, most likely. But looks like I'm running, Rocky 9.8 right now, 5.14.0, 687, blah blah blah, 17.1.
What firmware version are you on then? Could you do like the DMI decode something? Pull up what that was.
Sure, you give me the command, I can put it in.
Yeah, DMI decode -S BIOS version.
3A21.
3A21. Okay, we're on 3A14. So there is a newer version available. Well, hopefully Quanta can give that to me.
Yeah, hopefully. That ours came with it. I don't think we updated it. If someone did, it wasn't me. And I spent the most time with them, so
It is a pain to update them. I've done it twice now. It requires like 3 different reboots plus an
yeah.
AC power cycle. And so now that I'm
Yep.
fully remote, I got to bug my coworker to go into the data center and unplug it.
Yeah, these are at a colo, so it's even more of a pain. I might have done it when we first got them. I think I had to because it wouldn't boot up. It's been a couple of years, or a year and a half, I think. Yeah, I mean, aside from that, like circling back to the Warewulf side, I don't think we have too many issues aside from like what you've already stated, like the desire to provision the disk because the memory is precious because of the AI workloads that our users do.
Right. Having that giant memory space available on a single chip is huge. So I've ended up just templating most things using that .tags, that CPU arch, even things like the slurm d system d unit file. We did have multiple builds of slurm for the different architectures, so we just template it based on this CPU arch tag. Because we do a make build of slurm. We don't do the RPM builds anymore. Ran into too many issues with consistency across the nodes.
Mm-hmm.
The only exception is our secure environment where we have SE Linux enabled. Systemd doesn't like running random binaries as a root off an NFS file system. Go figure. Probably the best security move, but means I have to RPM build Slurm for that environment.
Why was doing RPM builds leading to inconsistencies?
There was, I think this was actually before Warewulf, so it's probably solved with Warewulf now. But when we were doing a maintenance, we did a big Slurm upgrade and noticed that for some reason, a handful of the nodes didn't get the newest version, or they showed that they had the RPM installed, but then the MD5 sum of one of the Slurm libraries was different on a couple nodes.
Wild.
And that was really confusing things. So after that, I said, let's reevaluate how we're doing this. Let's put everything into NFS, update a symlink, and restart a service so that we can also do this with Warewulf without having to reboot to pull in the latest RPM.
I understand now. It's not RPM versus make build. It's NFS versus local install, basically.
Basically, yeah. I call it a make build because we end up using
I just
tool,
mean in terms of the difference. The thing
Yeah.
that's making the difference is that it's shared over NFS. Okay, I got you.
It also introduces a couple challenges for the PAM Slurm adopt module. That one, because it's part of the PAM stack, PAM doesn't also want to reach out to NFS because, again, security or something like that. So we had to symlink in the PAM Slurm adopt libraries into the local file system at boot.
I'm kind of surprised that that was enough for it.
I am too. I didn't think that would work. And sure enough, it worked. That's when I also found out that lib64 was a symlink to user lib64 and broke all my nodes one
It
time.
is now anyway.
Just out of
Awesome.
curiosity, Josh, do you guys use IPv6 at all?
No, I try to disable it
Yeah.
wherever possible. I don't want letters in my IP addresses.
Yeah, our director of research is very set on IPv6. So that's
Does
our marching
he have to
orders.
manage a cluster?
Oh, he has many clusters, done that many times, not just at GW, but in his past life.
I was going to say, if he's a sysadmin with his hands on, he might have different opinions on IPv6.
Oh no, he's been a proponent since like what, 2006 or whatever. Yeah, he's forcing the university to adopt IPv6. So
I feel like it doesn't make a lot of sense for internal networks. Like, I understand IoT devices, smart devices, things that just reach out to the open internet freely with, a little bit of data here, but like on an internal cluster network, there's no need for more than, I don't know, even 65,000 addresses is more than enough for an HPC system. So I don't see the need for IPv6.
sure,
When I
but
was looking at it, the thing that made it really cool for internal was how you could just subnet everything. And it's not how many addresses you have, it's how many subnets you can make. And so everything could just have its own domain,
yep.
and you didn't even
So,
have to think about it.
Yeah, everything's under we have routers that just hand out Slack addresses. It's also makes it very easy. That's not the painful part. Painful part is other websites and applications supporting IPv6.
So I've been running the IPv6 prefix 64, and with the 64 gateway for about a year and a half now on my
Yep.
machine here, and absolutely no problems at all. There is work on a CLAT client side. We're built in eBPF, eBPF, eBPF. So it'll be pretty high performance. There are ones that exist already for a CLAT client, but that one is currently being worked on, and it's being integrated into Network Manager. So
Yeah.
that's a great solution. To me, it works pretty much transparently, and then you're only dealing with a single Slack, and IPv4 works pretty much transparently. You have a NAT box just like you would with a IPv4. It's just now it's a 64 gateway.
Yep, we have one. That's the first hop.
So are you using DNS 64 or prefix 64?
I believe it's a DNS64, unless Joe can correct me if I'm misremembering. I'm not sure what
You
the
think I know what it is?
The DNS64 takes IPv4 addresses and converts them to the prefix plus the embedded IPv4. Prefix 64, there is a payload in the IPv6 prefix or router packets that show the prefix 64, and then what happens is the CLAT device creates an internal, and you'll often see it on your phone at 192. Something IP address. So it's a real IPv4 address, and it even can tunnel ICMP as well. So it'll do a tunnel.
Yeah, it's not tunneled. I'm pretty sure it's a DNS64. I don't think our networking folks are as good as Clark. I don't know. Do you know Clark?
Well,
Clark Gaylord?
yes.
He's
But
he's
it doesn't tunnel it. It just converts it internally to a proper IPv6 address or an IPv6 packet. So there's no tunneling. It looks identical from the outside.
Correct.
The packets emitting from the machine are the same. It's just instead of doing the conversion, it does the packet conversion from 4 to 6 and then sends it out, as opposed to 6 natively, but it gets the IPv4 address via DNS. If that made sense to anyone.
Yes. I didn't mean like an exact tonal. That's just how I remember it, the difference between the two. But we do have a DNS 6.4 um, server.
And Microsoft is their OS is supposed to hit a CLAT client as well real soon. So that, we're really close to having CLAT on Linux, Mac OS, which has been there for a while, and Windows, which, suddenly makes your world a whole lot better
Mhm.
if you're going to do a IPv6 mostly environment.
I don't know if I've ever heard anyone say Windows will make your life better in a sentence before. It sounds like all the technology is there, and I just need to get past the reading of the letters and the IP address and start adopting. I'd read an interesting proposal about IPv8 recently, which looked like it was going to combine the best of both worlds. And I'm sure it's a long way out from being production ready, but I think it was the initial proposal to establish the standard.
Lungs and my boss had thoughts about that. He wasn't a fan.
Really?
He's not a fan.
Well, as long as it's been taking IPv6 to be really deployed, we'll all be dead by the time IPv8 gets there.
So if there are shortcomings in Warewulf, feel free to do a PR or document the issues. I've been working on trying to get IPv6 support a little bit better. We do need to do a refactor at some point in time to make it a lot less of a sort of a squidge in and do it properly.
Yeah, that was the other ticket I wanted to write just from our conversation on the Slack channel. With on the DNS mask side, I need to go over it again just to make sure I have my ducks in a row.
It is
You're,
hard
you're
to
having
get
a
around
DNS
all-
mask issue with IPv6.
Yes, between that and I guess my understanding of how it's implemented at this site.
And IPv6 in DNS masks does work well, but it is hard to wrap your head around what the options are and what options you should have. They've kind of conflated various aspects of the protocol and options into one line, so it's pretty obscure, and I have cut my teeth on that rather extensively. And of course, do not remember any of it right now. I just have some really good things that work on my Raspberry Pis, but yeah.
Like there's an A, there's an M, O, and then you
Yes.
flip some bits.
And it's also dependent on the gateways and things like that and how you have it set up.
Yeah, but I eventually got it to boot. Unfortunately, I have assigned an address and a Slack assigned address. So there's two IPv6 addresses on what I have. It's not ideal, but we'll iron it out later.
I've given up on trying to have only one IPv6 address. It's taken 10 years, but I'm finally okay with multiple IPv6 addresses. It seems to handle it just fine. So
Yeah, it's handled fine. It was just okay. It's good to know.
I feel your pain.
Help me get over it. Yeah, IPv6 aside, that's what we're looking at our Grace Hopper site. But thank you, Josh.
Yeah, thanks everyone for the good discussion today.
Yeah, agreed. Awesome. So Jonathan, I think you do have a little stop doing IPv6. There you go. There's some collateral for your guy.
Meanwhile, I gave a presentation once entitled "Stop Disabling SE Linux," so I think those are kind of competing ideologies right now.
Did you want to give the update now, Jonathan, that project?
Yeah. So there's not a lot to talk about in terms of Werewolf development. The two biggest PRs probably since last time is that there's support for group. I think this got merged in. Maybe it's not quite merged in, but we've got a PR in flight for groups of nodes and doing things with groups of nodes, which is great. Something people have been asking for a while. And then something that did get merged in that I saw here. What was it? Oh yeah. There's a PR for from a first-time contributor apparently, which is great. To when you do a set command, it shows you what is changing before, like as part of the confirmation dialog. So it was saying, do you want to change these nodes? Now it says, do you want to make these changes to these nodes, which is nice. But what we're actively trying to do right now is do a 471 that is just bug fixes. So if there's bugs that you are facing in Werewolf that you would like prioritized for that 471, if it already exists as an issue, like speak up on that and like maybe throw a link to it in the development channel on Slack, or reach out to any of us and say, hey, I want to see this in the release, and we'll try and get that prioritized. Otherwise, yeah, look forward to it, and hopefully we'll get a bunch of bugs fixed for the next one.
Awesome. So the last thing that we had on kind of the calendar to talk about, so maybe next time we'll just do one topic, but there was a second topic just in case. I should have known, Josh, you were coming in, and it would be a good conversation. But there was some issues with 10, with Enterprise Linux 10, some kind of problems there. So I don't know, maybe Fong, do you want to just kind of talk through real quick? And we're probably not going to get to it in the time that we have right now, but something to kind of think about and mull over for next time.
I mean, I can try it on the one Grace Hopper I've used to test stuff on. I actually haven't tried Rocky 10 on the Grace Hopper, so it's worth a try. See if we run into an issue.
So the note I got from Rose was that someone was having some problems, maybe with Open On Demand with Rocky Linux 10. I thought it was from GWU, but maybe not.
Problems with,
We haven't done any real testing yet,
Okay.
but
Yeah,
I've read horror stories.
It should, from a Werewolf perspective, it should just work. And on the server side, that's the Rocky 10 or EL10 packages default to DNS mask rather than ISC DHCPD because it doesn't exist. But other than that, it should be fine. But if there are problems with Rocky 10, love to hear more about it. But it might be a non-Werewolf issue. It might be something else.
Yeah, I think it's mostly around X11.
It's Wayland
lack
rather
of.
than I see. That makes sense. Okay.
But I've seen some interesting chatter. There's some people in the OOD community that have done some workarounds, I guess. Haven't really dug into it yet.
I don't know if Rose mentioned already earlier because I missed the first 10 minutes that will be at PEARC. But I think Open On Demand also has a BOF at PEARC that I expect there will be conversation about that in the BOF, but if not, that might be a good thing to go to and bring up.
Good point. Cool. All right. Well, thanks, guys. Thank you, everyone, for coming and showing up. And Josh, thanks for getting the conversation started. It was a good one. So we might have, continue the conversation. So you'll be at PEARC, right?
Yes. I finally got confirmation. I'm actually going to PEARC.
Are you talking to SysPros? In the SysPros workshop?
Possibly. I got to follow up with them because I just found out, I think last week, that I could actually go. Got the ticket, and I still need to get the hotel. Let me follow up on that today. I don't want to get there with nowhere to stay.
Yeah, that would be a bummer. I'm sure you could find a friend. Lots of friends are there. But
I'm sure. I just wish finance was my friend.
Yeah, finance. Well, because you're also coming from, now you went from dry desert Arizona to very wet. Is it raining right now in Seattle?
Not really. It's rained a dozen times or so, but it's always been like a pleasant drizzle. It's great up here.
Okay, good. Oh, okay. Well, that's great. I'm glad that you're happy where you're at. So PEARC will be there. It's Wednesday is the Werewolf BOF, Wednesday at 1:30 in the afternoon Central Time. So looking forward to seeing all of you there. Cool. All right. Thanks,
Thanks,
guys.
everyone.
Thanks, everyone.
Yeah. Have a wonderful day. We'll see you next time.
Thank you.